We got a nice, short, simple video, the power rule. What is the power rule, you ask? You're going to do it for me. Because, I don't feel like working today. I'm just going to make you guys tell me what the power rule is. So, example 5. What if I ask you to expand the natural log of x times x times x? And again, let's notice this is x cubed. We can expand x cubed just with the product rule, right? The product rule from the last video said that if you multiply on the inside of a logarithm, that's like adding their individual logarithms together. So this is the natural log of the first, plus the natural log of the second, plus the natural log of the third. Well, I'm adding together 3 natural logs. They're the same natural log, so how many do I have now? Now I have 3. That's the power rule, right? It doesn't matter how many x's I had, right? If I had 4 x's, x to the 4th, well then we'd add up 4 of them. We'd get 4 natural log. If I had 6 x's in here, well, we'd be adding together 6 of them, and now I'd have 6. We can expand that in general. That's going to be the power rule, which says that log base b of x to any exponent, that exponent comes down in front as multiplication. And I've said that logarithms are just like exponents. So what is this saying? Well, this is related to that exponent property we've been using for a while, right? If I have an exponential function raised to another exponent, we just multiply those exponents together. Multiplying these exponents together, kind of like so. That's the correlation. You could show all of these using that method from the last video as well. All right. So if we have an exponent inside of a logarithm, that exponent comes down in front as multiplication. That's the power rule. Let's use it with example 6. Expand log base 3 of 1 minus y to the n. I want to do this in 2 different ways. Let's do it in 2 different ways. The first way, let's use the quotient rule first. Log base 3 of 1 minus log base 3 of the denominator. Well, we can simplify both of these even more. 1 is 3 raised to the 0th power. So these 3's are going to cancel with the inverse property. This first thing is just 0. What's the second thing? Power rule says the logarithm of an exponential function, the exponent comes out in front as multiplication. This becomes n times log base 3 of y. Well, that 0, we don't have to write it. This is just negative n log base 3 of y. This is what happens when we expand this out fully. But you could have also done it another way. You could have also had said, well, this is log base 3 of y to the negative n power, right? A negative exponent just means reciprocal. So 1 divided by y to the n is just the same thing as y to the negative n. That negative exponent just flips it upside down. And then you could use the power rule directly. The exponent is negative n. We get log base 3 of y like this. So there's 2 ways of looking at something like this. Let's do one last example here. Example 7. Combine the following. 1/3 times the natural log of 8. We can go the opposite direction, right? If I have multiplication on the outside, that can come up here and jump into the exponent, right? This can go up here, right? It's the same thing. We can go in both directions. So let's use that. This becomes the natural log of 8 to the 1/3 power. And we can simplify this even more. fractional exponents have to do with radicals. Becomes the cubed root of 8, which is just 2. And again, there was another way of doing this problem as well. I don't recommend doing this red way, but you could also have said this is 1/3 times the natural log of 2 cubed, and then use the power rule in this fashion. This becomes 3 times 1/3 ln of 2. 3 times a third is just 1. So another way of looking at a lot of these. And that's the power rule. That's all there is to it. So let me know if you have any questions, and good luck.